麦克风测了吗？
better. Yeah, it won't match.
就测那个。帮我看，帮我看。先把这个。Sorry, mic.
Oh, sorry.
Yeah. It's okay. Test. 都测一下。Test. Test. Hello guys, so we will start in 1 or 2 minutes, so please have a seat. Okay, so welcome everyone. It's wonderful to see you guys here. My name is Yuan Zhu, who is one co-organizer of the Taipei Ethereum Meetup. So today, it's our pleasure to invite so many important guests in Ethereum ecosystem here to share their idea about the Sharding clients and the general Ethereum research topic. Probably a lot of you guys know Taipei Ethereum Meetup is a developer-based community. So yeah, we always share some Ethereum related topic to our members, and also want to help engineers to get familiar with the Ethereum to get more energy to this community. So sorry, I'm a little bit nervous. So this is perfect to see a lot of developers here. So let's give a big hand for them. And tonight, not only the guests on stage for the panel discussion, that we also have a lot of people from different projects or company related to the Ethereum Meetup, Ethereum blockchain, include the Ethereum Foundation, Parity Tech, Status, Consensus, and Prismatic, and Link Time. So, okay, so let's get started. So let's welcome Kyle.
Hello, everybody. All right. It's lovely to see everyone. We've got some exciting panels with some of the most exciting people in the space. Oh, my goodness. It's the. Wow, I gotta fill up this chair. We gotta be tight. Oh no! I forgot. Oh no! Miscounted. Apologies. No, absolutely not. I clearly did not understand where this was a seat. Anyway, so this is the third day of a massive sharding workshop, and these are every single person here has been day after day tirelessly working on sharding, talking about sharding, and talking about Ethereum and enjoying ourselves. So I think we should start out by introducing everyone. You can say your name, company, etc.
All right, hello everyone. Nice to be here. I'm Jacek from Status, working on obviously a sharding client like the rest of my fellows here. Yeah, hope it's going to be a nice night here.
Hi everyone, it's great to be in Taipei. So my name's Ben, and I'm from Consensus. Consensus is 700 people now, working almost all of us on the Ethereum blockchain, and I lead a research and development team in fundamental Ethereum protocols.
I'm Piper Merriam. I lead the Python team at the Foundation and have been code reviewing all of the wonderful code that the Sharding team here in Taiwan has been submitting.
Hello everyone, great to be here. My name is Frederick from Parity Technologies. I'm a core developer there, and yeah, hoping for a good discussion here.
Hello, I'm Peter. I'm leading the Go team in the Ethereum Foundation, and mostly I've come here to try to understand how we can cater for the whole sharding and how we can support it from the lower levels.
Hey everyone, my name is Raul, and I'm the co-founder of Prismatic Labs. We're an independent team working on a sharding client for the Go implementation of the Ethereum protocol, and happy to be here.
Lovely. Well, I'm sorry. I'm Carl. I forgot to say that. I'm an Ethereum researcher. Anyway, I follow this Ethereum project, but what is sharding? And I would love, who can explain sharding to me? What is it?
At the base level, right? Imagine the current blockchain. If you have 10 transactions that are pending, blockchain is going to have to process each one of those transactions sequentially. Every single node on the network is going to have to run every single transaction. With a sharded chain, you're able to kind of, split the blockchain into n shards, and these n shards are going to be able to process these transactions in parallel. So it gives you a quadratic speed up.
Yeah, I think one way to think about it is like adding more CPUs to the virtual machine that can run more things in parallel. So many different shards mentally map well to many different CPUs on the machine that are all able to process in parallel.
So why don't we just add more CPUs to our machines? I
think that's what we're doing. But I think the question you're asking is why don't we just do that with the main chain? And the general reason is that parallelizing the processing of the current EVM doesn't give us the guarantees of deterministic outcomes when different people run it. So everything runs synchronously, which basically makes it like a single-threaded application.
Another interesting aspect or interesting comparison would be the search engines before and after Google era. Whereas every search engine before Google, they tried to really scale their hardware. And that kind of worked well, but it was really expensive. It's kind of similar to how Ethereum runs now, that we try to really push the limits of a single system, but it kind of works, but it's not really optimal. And then Google's brilliant idea was that instead of investing extremely expensive hardware into a single system, let's try to break that system up into little tiny chunks, and let's try to somehow figure out how to distribute those chunks so that all the tiny components can work together. And essentially, that's the same thing that we would like to do with Ethereum, that if we can replace the one big mighty system with tiny small systems, then all of a sudden everything gets faster. Of course, the challenge is how do we do that?
And it's not just about the technology, it's about the ideology, if you like, of a distributed system, a blockchain, to make it democratic so that everyone can participate on their laptop or their cell phone or whatever. We don't want it just people who have supercomputers or server farms who can participate in securing the blockchain, but everyone should be able to do this.
Amazing. Well, it sounds pretty difficult to do that. I'm curious, what kind of challenges do you foresee? And this can be either, in the client side. I know we actually have 2 groups here who have already started implementing sharding, but it can also just be from architecture. We've talked a lot over the past few days.
Yeah, well, obviously, one big deal is to sort of maintain this ability to run it on all kinds of devices, and at the same time maintain security at an acceptable level. And a lot of what we've been talking about here is sort of ways to avoid state, for example, because the state keeps growing, to run stateless clients, or to at least have a model where some people can avoid to know everything about everything going on out there.
Another consideration is that, like sharded systems aren't something new. You can envision sharded systems, sharded databases in traditional computer science. However, a lot of these rely on having sort of a centralized coordinator and someone that is able to kind of guide what's going on across the shards. And in this case, in Ethereum, we have to do it trustlessly, and it just introduces a whole swath of security considerations that we never had to deal with before. And I think the Ethereum Foundation and everyone here has done a really great job at putting on a few days of intensive research and understanding of how we could go about this.
Another very interesting challenge is that, for example, when you try to, even in classical databases, sharding is a well-known thing, that you just basically figure out how to split your data up into meaningful chunks. You store it on different machines, and everything works. So in theory, it seems like a simple enough solution. Now, in practice, the problem is that Ethereum tries to be generic, and we do not know what we want to put in those shards. Now, this means, since nobody is designing the data contents of the shards, rather the individual users building on top of Ethereum will implement it, this kind of means that we don't know the dependencies between those shards. So even though for our own database we can clearly define that we will put some data in one shard that is completely independent from other data, but with Ethereum, it might happen that data between 2 shards that are put on different shards actually have a tight dependency between one another. And this is a real problem communication-wise, because how do we get data across shards, or how do we make sure that if, for example, one shard there's a rollback or a reorg, a fork, then how do we handle data that depended on that in the other shard?
Yeah, cascading chain reorgs are sort of nightmarish and hard to think about. Today, at least for a while, we ended up kind of down a rabbit hole of talking about that sort of inter-shard communication. How do we let things on different shards talk to each other, and how we kind of mentally map those to concurrency models in, programming languages that we use, and the various pitfalls in those concurrency models and deadlock situations and things like that. So there's a lot of different topics that we've been going over for the last few days that make some of this really interesting and kind of terrifying at times. And yeah.
No.
Well, I wanted to broaden it out, not just talk about the difficulties, but the opportunities that it affords. It's not just about scalability. We've been talking, it's because the main chain, nobody wants to fiddle with the main chain because it is what it is and it's worth a lot of money. Nobody wants to break it. But doing something with sharding allows us to explore all the really cool new technologies like eWASM and stateless clients and all sorts of exciting new directions for Ethereum. So that it's not just about scalability, and that's going to be challenging, but it's also very exciting.
How about one of the topics that we've discussed quite a lot was rent. And I'm curious, as client developers, shout out to Phil Diane.
Obviously, everybody loves paying rent.
Everyone loves paying rent. So maybe first, what is this kind of rent thing? And what are your thoughts?
Well, I think it's pretty obvious that the growth of the blockchain is not sustainable indefinitely the way it's going right now. It's growing quite fast, and eventually, like we were saying before, we'll get into a situation where there's so much storage on chain that a normal home computer can't run it anymore, and we have to move to servers or server farms. So the question we're trying to answer is like, how do we reduce that? And one idea is to actually make people pay, per unit of time for their storage instead of a fixed fee. So this is a storage model that everyone is used to. That's how we pay for storage everywhere else in the computer world. So, I think it's a pretty natural thing, but it's a very distinct difference from how things are handled right now. So it kind of breaks all the expectations.
So one thing I forgot to mention is I think it would be great to clarify the difference between historical data and blockchain state and what that kind of means. And then we can talk about how rent plays into that.
So essentially, when a blockchain, new blocks are added to the chain, you kind of have the blocks themselves, which just contain the transactions that were executed on top of the previous blocks. Now, this is an immutable historical data that nobody wants to touch. However, on top of this, so this is just a transformation function, so to say, a transaction that transforms the old state into the new state. Now, beside this, we have the actual state of the network, meaning that how much money do I have, or what data does a smart contract has. Now, even though we do not want to touch the immutable parts, the transactions themselves, because those are important to reconstruct the entire history to validate everything, do we really want to store all that smart contract data that was inserted there? Now, obviously, if I have my account, I would really like the system to remember that I still have funds on my account. Or if we have a popular contract, we actually want people use, we want that contract to stay around. However, for example, the Ethereum mainnet has one of the smart contracts, the data content is a Windows computer virus. Now, although it doesn't bother anybody, why should that be left there for the end of time? And then there are lots of cases where the data itself not really needed anymore. Nobody uses it anymore. Maybe it was a contract that we deployed 2 years ago. It was really popular. Everybody used it, but we upgraded it. Nobody is using it now. So there's no reason for that contract to stay alive. But, of course, as it was already mentioned, the current model is that if I deploy anything, it will always be there, whereas this is a really, really exotic mind shift that it might not be there eventually.
One important thing to consider here is that this can be a controversial topic because for the community itself, Ethereum has been basically subsidizing this time value of storage to the point where people that create smart contracts have an easy time. They can just store this forever on the blockchain. They don't have to worry about the time cost of it. And that was, I think, fantastic for the growth of Ethereum. And introducing a topic such as this, the fact that now you're going to have to pay rent for storage instead, can be extremely controversial and a really hard pill to swallow for people. So that's something that we were discussing a lot the other day, how we're going to introduce this topic to the developer community and how can we capitalize on how important this is for the long term.
And the important thing to note here is that the solutions we're thinking about, so we're trying to think of a smart way to solve this problem. So we don't just want to say that, okay, everybody's going to have to pay from now on and period. Rather, we are trying to figure out ways that, for example, if I create a smart contract that is used by people, could we somehow make keeping that smart contract alive implicitly part of the transactions that use them, so that it's not like the monthly Ethereum bill arrives and I have to pay it, rather than it's it's handled by the system under the hood, and if for example, we have a CryptoKitties smart contract which is used by hundreds or thousands of people, then essentially it will be a negligible, an unnoticeable fee for every one of those users. So for any meaningful contract, the ideal system should form in such a way that you don't notice that you are actually paying some micro fees to keep it alive. At least that's the dream.
I would actually add to that like in today's world, we're also paying for the storage of data with traditional services, we're paying for it with privacy and control or lack thereof. On the blockchain, this is all transparent and people have a choice to subscribe to the system and they see what this payment is. I would add that as a very important aspect of what we're trying to do here.
Cool. And I heard after the rent discussions, after the sharding discussions, some backroom talk about a interesting scheme to kind of shard in some ways the historical data. And I'd love to hear about that, because that's even different from sharding the main chain. And how is that different?
Well, Carl, let me tell you.
Ooh.
So after the very difficult discussion about rent, Peter gave me some info on just sort of what your hard drive is going to look like after fast sync right now. And
you don't want to know.
The footprint is something like 60 gigs, but only about 3 of that is the chain state, so balances, smart contract storage. The other, roughly 57 is blocks and transactions and receipts. And that information is much less controversial to, well, first of all, we can't charge rent for that because that's not actually part of the chain state. So we were looking into other alternatives for how we can kind of minimize that footprint. And so we're looking at ideas where we effectively sort of shard that information across the network itself. So probably starts as opt-in features, but basically by enabling a flag or something in how you run your client, you might store only 1 out of every 2 blocks or 1 out of every 10, things like that. So we can make a really big dent in the hard drive footprint of running a full Ethereum node with that strategy, and very easily drop that footprint down to the sub 10 gigabyte mark or less, depending on how confident we are that we can shard that data across the network and still have good availability for it.
Yeah, and the challenge usually with these is that although from the outside it kind of looks trivial, just store every second block, from the inside this breaks a very, very important system invariant that we currently have, and that is that every full Ethereum node has all the blocks. Now, this doesn't seem like such an important invariant, but from the networking protocol perspective, for example, there's a network packet which says, give me the next 100 blocks, for example. Now, if you only have every second of those, then all of a sudden, this can cause nasty issues. These are all solvable issues, but it's really interesting to see that there's a trivial idea. In theory, it looks like it's trivial to execute on, and the entire network collapses under a false, basically just by breaking an invariant.
This is why client development seems terrifying to a researcher. And so I'm curious, you kind of started touching on the networking layer, these interesting interactions between clients, and I'm curious if you could just fill in, what is it like to have to, networking, consensus, making sure that this network is healthy at all times? Whew.
That's a horrible experience. So it's actually every day you look at the network, ETH stats and stuff like that, and you wonder what horrifying metric you're going to see there. Whether that's somebody launched a new ICO and the whole network bent under the load, or it's basically, as we are constantly pushing the limits of Ethereum, every day we kind of discover something that worked previously but doesn't work now. For example, just a typical bug in Go Ethereum, for a long time fast syncing consumed an enormous amount of memory. And basically we couldn't really find issues, and we tried to find why, and it worked perfectly until now. And simply it turned out that our buffers were a bit too generous, and since we pushed up the gas limits of the blocks and the transactions became much data heavier and the receipts became much data heavier. Originally nobody used logs. Nowadays every smart contract is emitting logs. It turned out that it was a huge memory load on the node. And that's a thing that didn't show up at all for 2 years, even though this issue, so to say, was present in the network and in the client for 2 years straight. And there are lots of these tiny issues which are completely oblivious, and then there's something happens in the network which triggers it, and all of a sudden everything dies a horrible death.
I think it's also a little bit of a death by 1,000 paper cuts story, where since state and everything keeps growing so fast, you keep running into having to optimize something. So with Parity, we launched Warp Sync 2 years ago, and it worked perfectly, and everything was fine and dandy. And the further along we've gone, the more our assumptions around Warp Sync have been breaking. And so like one thing now is that a snapshot that you download with Warp Sync is so large that it's actually more common that your pair will disconnect before you've downloaded the whole snapshot than you are able to download the whole snapshot. And so our sort of assumptions around how this networking behavior works have broken down and changed, so we need to change our algorithms and how we actually build these things.
Or for example, there are also issues when where one client does an update and breaks the other client. For example, we did this both ways with Parity. One of them, at a certain point when the spam attacks started, or I don't know, when the chain started to grow, Parity, they realized that they can, instead of keeping a lot of trinodes or a lot of data past state, they started a much more aggressive pruning. And from their perspective, this was obviously the good choice. Now the problem was that Geth, the fast synchronization in Geth assumed that you have the state of the past 1,000 blocks. Now since Parity pruned it, all of a sudden Geth had a huge problem to synchronize the network. And essentially then we had to release an update on our side just to hack around the hack that Parity introduced. Or a similar thing that happened was when we updated our networking protocol, introduced compression, did a release, and all of a sudden, again, Parity and Geth nodes stopped talking to each other because it turned out that there was a tiny bug in Parity which caused a minor networking conflict. And these can be really nasty when, especially, okay, these kind of, we realized these quite fast and they were quite easy to catch. But when such a modification slips in and it appears a bit later, it's really hard to track down what went wrong.
So, and this is like a decentralized blockchain development process where different organizations that really aren't, built to communicate very much, probably like have to work together in some ways. How does that process actually work? I heard of these EAPs, but outside of that, I don't know.
Well, I would actually say that one of the greatest advantages of being at a conference like this is listening to these anecdotes, listening to these little experiences, maybe not even in the conference room, but outside by the coffee table, and sort of hearing these little symptoms of where the network needs growth, where the network needs research, where it needs development, and that sort of leads us to look for solutions, maybe even like rent, like we see that, state is ballooning, what are we going to do about it, right? And these are opportunities to anticipate problems and to try to deal with them before they become user experience issues where the network itself starts buckling under the weight, right? So.
Yeah, I think having these kinds of meetups with like client implementers and like both teams that try to write new clients, share experiences. We were talking about before of like trying to establish a list of these kinds of bugs and other things just to share experiences more. But I think the cooperation, like you're saying, it's a bunch of disparate companies with different interests and completely different locations usually, and working together is not non-trivial. And getting together like this, getting together online more, I think something that I would look forward to.
And another interesting aspect that we must never forget in Ethereum is that even though there are a few important players in the sector like the Ethereum Foundation, Parity Technologies, and other major companies, Consensus, and even though these companies are heavyweights, that their opinion counts quite a lot because they kind of proved themselves that that they managed to build an entire system. Nonetheless, Ethereum is supposed to be a global distributed system, and it's supposed to be, it's not supposed to be controlled by 3 or 3+ companies, which means that we can't just go behind doors, decide that, okay, the next protocol will contain this and that changes and period, everybody upgrade. Rather, we really need to somehow involve the community to get feedback from the community. Now, of course, certain people, the words of certain people always have more weight because they have the experience to back it up with. But nonetheless, it is really important to give a voice to every single individual and not just have people represented by companies, rather than if I or anybody from this room wants to mention or contribute to something, they can actually individually do that.
Yeah. And as an example, my team is an independent team. We're a bunch of protocol developers. We were excited about how transparent the community is, how easy it is to, to discuss with the key members of the community and propose issues, pull requests, and such. And I think that really pushed my team to come together. And in just 2 months now we're here. We're working alongside the other client implementers. And it's amazing kind of what having an open source transparent community can do. And yeah, giving a voice to the developers, because at the end of the day, and for the users as well. They're the ones that are going to be using the blockchain for its purpose. So.
Yeah, just to endorse that, I mean, at Consensus, a large part of our target market is enterprise Ethereum. And, we could do that without the community. We could build a closed source client and service that market. But we don't want to do that because we feel that the community is everything for Ethereum. It's what it's all about. If it's not for the community, then the whole thing is pointless. So we're building a client. It will be open source, and we very much hope that many people will use it. It will be fully public chain compatible. Now this is a pain, right? Supporting the public chain. We don't need to do that, but that's really important to us because it's an engagement point with the wider community, and we want to build, accept pull requests, bug reports, and everything from everybody using and working on our client as well.
For example, to give an example where the community was really valuable in this whole process. Now, from Ethereum protocol perspective, everybody heard about ERC20 tokens. Essentially, almost all tokens are backed by a single specification, single proposal. Now, from the Ethereum's protocol's perspective, that proposal is completely useless. I mean, it doesn't matter from the protocol's perspective, yet from the app developer's perspective, that is what makes a world of a difference. And so essentially, that is why it is really important to have community feedback, because the community is the one who's actually building on top of the platform, and they are the ones who actually know what the pain points are and what they would like to solve. So it's obviously our goal is to cater for, we want to be a platform. We want to help people build on top. And the only way we can do that is if we have feedback from the community and a constant flow of information and ideas from the community.
It's also just interesting work. I come from the world of web dev, and web dev is awful.
Yes.
It's just integration after integration with little sparse sprinklings of actual interesting problems to solve, and mostly you're just doing the same thing over and over again. And transitioning into
I bet you can't center a web page.
Transitioning into this world and building out an Ethereum client, I have too many cool problems to work on, and it's a good problem to have. Or
Yeah, I'm actually gonna back that. Like, there's compiler technology, there's network technology, there's peer-to-peer, there's distributed systems, there's storage, there's crypto economics, there's crypto itself. You can go towards the theory, you can go towards the practical, you can go towards the user experience. There's really so much interesting stuff going on, and I don't know if I really invite people to join the process, join the projects, foundation, Parity, us, whoever it might be, right? But there's just so much interesting stuff out there.
there's also something really satisfying about there being a correct definition of your software working, as opposed to like whether or not the login button is in the right place or whatever other dumb UX web problem, all of them that I worked on for years, whereas there's so many really cool hard problems that I've gotten to work on and finish and say this is done and it works and it works exactly right probably.
I agree with that. I mean, one of the things that really attracted me from the start is that you're implementing a protocol and either you're implementing it correctly or not. Like there's no in between. It's kind of nice.
That was one of the most beautiful things. Peter, please take it away.
And of course, there are the nasty challenges when when actually you implement the protocol correctly and the other team implements the protocol correctly, and it turns out that they implemented it differently. And because the protocol wasn't spec'd out correctly and it was ambiguous. And then the network falls apart. And then you try to figure out who's at fault. And it turns out that nobody was at fault, but the network fell apart nonetheless.
It's one of the cool parts, though, because it helps us find where our spec is broken. As
Easy for you to say as a minority developer.
Fair point. I'm a white man in his 30s. I'm not a minority. Oh, that was terrible.
Whose fault is it that the protocol is wrong? The researchers, right?
My website is carl.tech. Please reach out with all of your protocol problems. Sorry. So wow. I mean, seriously, that was amazing. And I also was a web developer, and I also hated it. I mean, I made like some reasonable money pumping out those websites, but this space was like so ideologically amazing. And so I'm curious.
Pumping out tokens makes much more money, right?
Yeah, I know. I started saying it and I realized that, and I was like, oh God, why am I talking about money? But no, like, how did you like get into the space, or how would you suggest people get into the space? Because I always want more people from different communities to get into this space, and I think that's probably the main thing that we need, because we need a decentralized developer base.
I think I can speak to that because it's, especially for people that kind of know about blockchain but have never really seen the source code for a client. I think that it applies to a lot of people, and it's really easy to scratch the surface and spend your entire time just reading articles about proof of work, like hashing algorithms and such. But until you actually dive in and try to like launch an instance of Geth or Parity, then you start realizing, okay, like this is interesting. I want to take a look at how this works. And at that point, that's when you start going down a rabbit hole of implementation, understanding the deeper meaning behind things, and then you get to the point where you want to build it yourself or contribute, and you start seeing bugs, and you start seeing where it could improve. And I think that was a breaking point for me to want to get more involved in Ethereum. And I feel like that's kind of like the checkpoint that I would advise a lot of people to get past. Start actually launching one of these clients, try running the code, try changing something, see what happens. And running on your own local computer. Don't mess up the main chain. But yeah.
Well, I can add a bit of color to that. I have a background in a little bit of peer-to-peer networking, a little bit of compiler technology, and a little bit of other things. One of the interesting themes here is that when I was steeped in this peer-to-peer thing, this whole information wants to be free debate was raging, and there were a lot of ideological battles going on between closed source and DCMAs and pirate bays and whatever those things might have been at the time, right? And now we see new technology latching on to that stuff that was developed years ago, right? So there's this progression of technologies that add up to something which becomes even more interesting as it continues growing, right? And being here and being part of that and sort of forming what technologies we will have in the future, what technologies will be built upon the stuff that we do today is really, really exciting. So that's like a path that I've taken, and I look back and like, those years formed me, but now I feel that we're part of something that's going to form a lot of people in the future as well.
Yeah, 100% endorse both those. And you know what Raul said about just get involved. I was 6 months ago, I was in a dull middle management job in a Japanese company. I was not allowed to do anything technical anymore. And I was spending all my evenings and weekends doing stuff on GitHub. And you know, now I made my hobby my job. And that's just the way it is. At Consensus, we're hiring. You'll get noticed. And we'll come and talk to you.
Yeah, I usually get one hiring email from Consensus every week.
How is your Node.js?
Oh no, you're not the only ones hiring.
Well, I'm not a panelist, but I can say that I was interested in this space and you know, watched a bunch of YouTube videos, and I can say 100% that there is so much out there if you just spend a lot of time looking for it. And it is a lot of time, granted, but this is something that really, like, every single person should, the information needs to be spread, and if you work twice as hard to like find it and then spread it to your friends, I think it'll do a lot of good, because I think it is a revolution in some ways.
Just to add to that information is hard to obtain, or it's not trivial to jump in. As an interesting thing on how I started working at Ethereum, after I joined because it sounded like a cute project that was implemented in Go, mostly. I joined because it was implemented in Go. And after about 2 months, I finally understood what I'm implementing. So it's not something that you can just look at and understand from the get-go. It requires a bit of digging in, but then it becomes really, really rewarding.
I would actually also say that I joined Parity because I wanted to write Rust. But there was obviously, like you're saying, like I was actually involved in cryptocurrencies for a while, but it never really grabbed me all that much until I found that you could write decentralized applications and actually like build a whole kind of ecosystem on top of that. And that's when it kind of hit me, and I realized that it can actually be impactful even beyond just currency. So I thought that was really cool, but I would encourage people to like jump in, like everyone else is saying, just find a project in a language that you like, jump in, start tinkering, read some paper or whatever you want. I mean, there's so much to be done in this space. Like, we're so early in the development of this, and there's like a ton of stuff left to do. There's infinite work available, so it's just jump in and do whatever you feel passionate about, whether it's language development or tooling or building an IDE or whatever it is. And I was talking to John from the Ethereum Foundation earlier on like the grants and funding that is available. So like it is actually possible to work for the foundation even if you don't become an employee or like with money from the foundation.
One quick thing is that there is a lot of information out there, but it just takes a lot of experience to kind of filter out what's valuable from all the noise. So I think for anyone that's trying to get involved, definitely try to pick up information from the original sources or try to read kind of official documentation or some of the official clients. There's a lot out there that you can just get lost in and kind of regurgitated information. So definitely just be wary of that and learn how to filter out really valuable info.
Yeah, I would reiterate that we are still very early. There is a ton of stuff that still needs to be built. That there are plenty of programs out there that can let you start contributing with very low risk. Find one of the bounty programs, things like that. And there is a lot of need for people to work on things that aren't ICOs and things like that. There's a lot of tooling that needs to be built, and focusing on that actually builds something lasting and useful rather than being part of the 99% of projects that are going to fail.
How much time do we have? Is this good? Okay. Well, that was incredible. Thank you so much, everyone.
Thank you,
Thanks,
Carl.
Carl.
Thank you. Get involved, everybody. It's fun. If it's not 3 a.m.
好，我们中场休息到8:25，所以大家可以就是起来跟大家聊聊天啊。
直播之外还是有录下来嘛，对不对？直播就直接在网络。对，没有，他会直接存档在网络上。OK， 结束马上就可以看了。
Oh. Panelists, victims, feel free to sit down. Yeah. State execution, yes. State execution. Okay, so welcome to panel number 2, where we talk about sharding and research topics. Though before that starts, I also wanted to mention that the Ethereum Foundation is also hiring. And so, like, if you are interested in becoming a researcher, becoming a developer, working on any kind of like base layer infrastructure project, then always feel free to reach out to us. Feel free to reach out to probably the Taipei Ethereum Meetup organizers, and they'll forward you along to us. We're always, whether you're interested in becoming an Ethereum Foundation employee or applying for a grant or anything else, we are always happy to hear you out. So, thank you. Okay. Okay, you go.
Wow. Well, this is amazing. These are like my idols from the internet. So like I shouldn't even have to talk very much at all during this panel. And so I guess we could start off with what is Ethereum for? Because I didn't know sharding, and I don't even know what Ethereum does. ICO?
Yeah, I mean, Ethereum is just a platform for ICOs, and the only ICOs that it's for are ICOs for other ICO platforms. But like, it has to be well-founded. Like, you can't have like an infinite ICO tower. There has to be stuff eventually. No, seriously though, like the question of what blockchains are like actually, and Ethereum particularly, are kind of good for is a very interesting one. And it's like there's like fundamentally speaking, right? Like blockchains basically let you do kind of stateful, decentralized applications, as I've often, like to say in presentations where I describe blockchains to noobs. And what are the two parts of that, right? So stateful basically means that there is some kind of information that you want the system to keep track of, and where like you want to have some very strong assurance that kind of the state of some application will like basically progress according to some rules, and that it's not, it's never going to revert in some way, and that it's never going to like progress in some way that violates the rules of the system. And decentralization is pretty simple too. Like basically it means that like no one controls it, that like the system can survive even if the original developers disappear, and even if the original developers, once they build the application, like try to, like in some way cheat, attempts to defraud their users, attempts to interfere with their users, like they don't have the ability to do that. So, like basically anything that benefits from being decentralized and anything that benefits from being stateful is at least fundamentally a good blockchain, a kind of possible candidate for a blockchain application. So, like the first and most obvious one, and the one that like the space was kind of created around, is like cryptocurrency, and like just all of the different applications of like cryptocurrency and like digital money more generally. And like that includes both kind of things like Bitcoin and Ether. It also includes like more interesting stuff like MakerDAO, which is basically trying to kind of create a decentralized like central bank on the blockchain that's run by a DAO. So you can have different currencies with different monetary policies. With a smart contract, you can basically make applications where those applications have the ability to kind of control money directly, and so you can do a lot of things that would have previously required like basically one central party to be kind of managing everyone's funds for some amount of time. And with smart contracts, like not all of the time, but some of the time, you can remove the need for that. So like this includes like stuff like insurance. This includes like things like assurance contracts, like a lot of like many types of crowdfunding, like various market mechanisms. It also includes like some like even just like decentralized exchange, atomic transactions, like the ability to kind of like reliably do multiple things at the same time. There's also like you can use blockchains for things like other than cryptocurrency as well, and that was kind of a lot of where the original vision for even Ethereum came from. So, like one example that like a lot of people talk about is just like basically like different aspects of identity management. And like one particular one is just like key revocation or key updating. So basically, if like you have a private key that you use to sign messages with, that kind of represents some kind of identity for you, and then you might want the ability to like basically revoke the key or replace it with some other key. Or you could have multiple keys. You might want to replace some of those keys, and like that's a stateful mechanism, right? Like the reason why you want to replace a key is because you're worried that it might get hacked, and maybe eventually your key will get hacked. But if you've already replaced it, then like that's not a problem. So, like the reason why that's stateful, is that like basically it fundamentally like it matters in like who did something first, and that's something that like blockchains and smart contracts can also be fairly good for solving.
Yeah, no, I think that's an excellent overview, but just this conversation is something that we do very often with the developer community, so I think it's good to also not only have a bunch of examples, but have a framework to think about like what makes blockchains useful. So I think this conversation wouldn't be complete without talking through what blockchains are good at and what blockchains are really bad at. So what blockchains are really bad at is just being a database. So it's a very expensive database because you might imagine a bunch of computers come to a network and they all do the same thing. That's crazy from like a distributed systems perspective, right? Because Amazon was successful because they do the economies of scale really well. They provide things really cheaply. So now that we talked about what they're bad at, what are they good at? So I think about it in three prongs. One is digital collectibles. So you might have as more of the world gets digital, you might have a concept of like something that is in the digital realm that is uniquely yours. That was not possible. Like if you have a PDF online, that's not yours. It's a copy of a digital PDF, right? But now you might imagine, whether that's in a game or in reality, you might be able to have a digital asset that is uniquely yours. So on top of that, I think there's going to be a lot more interactions that are available. So number two is programmable money. So whether that's cryptocurrency, but also derivatives, you might imagine all sorts of things that you own today, whether that's debt or equity or whatever assets, being more minutely being able to be programmed, right? So like you might be able to own like 1/1,000,000th of the Empire State Building programmatically in the future, and what can you do with that kind of API? The possibilities are endless. And number three is really around like self-organization, and this is kind of like more the futuristic and the ethos that is driven. Like society has been organized recently in the past few hundred years around like geography and nation states, right? But what if we can organize with people that you're just like-minded? So what if you're really into a single type of like programming and you want to have a organized like group around it? So like in the beginning it might be just like a hobbyist group, but you might also imagine like a economic kind of linking between major cities like LA and Paris and Tokyo that don't have any nation state ties, but they could have a ledger with each other. So that one's a little bit abstract, but it's the concept of self-organization. So the three things are very different, but if you think about it, it's just really about disintermediation. So when I read the book Sapiens, like it really talks about how did our species kind of continue to self-organize in larger and larger ways, and how do you go from like very smaller and disparate groups of people to organizing past Dunbar's number, like 150 people, to create more progress together. And I think this technology is not only about like scaling and privacy, but it's really about people. Like how do we organize together without trusting larger entities like banks or governments, while working with them, right? So like how do we use that? So I think that's really why blockchains are exciting.
So I'm kind of the independent researcher here, so I guess I get to say the more controversial stuff. I think this is a phrase I first heard at Consensus, which is that, maybe out of Consensus, which is that what blockchains are essentially good at is being a trust minimization machine. First of all, let's start with the term trustless. So a lot of people, when they talk about blockchains, they talk about trustless systems, trustless execution, et cetera, et cetera. Blockchains are certainly not trustless. When you run a blockchain, you're trusting a lot of things. You're trusting that our client developers that were on the previous panel have done a fantastic job of making sure all of their code works. You're trusting that the network is going to be available. You're trusting that the internet will continue working. You're trusting that your computer will execute these things appropriately, et cetera, et cetera. So there's like a huge space of things you're actually trusting. But if you think about it in sort of the old centralized model, you're still trusting these things anyway. So what blockchains sort of allow you to do and what they're really good at is when you have an application that's run by a lot of different people and none of them sort of have any common root of trust. So we want to work together. We don't trust each other. We don't trust Amazon. We don't trust Deutsche Bank or anything like that. What a blockchain allows us to do is sort of verify each other's actions independently and prove misbehavior to sort of everyone else in the system in a way that misbehavior can either be punished or acted on or even just detected. Two fantastic applications of this that I think cryptocurrency has been wildly successful in so far have been gambling and drugs. These are sort of perfect examples of systems where you have a lot of different actors, none of whom trust each other at all. Blockchains actually provide fantastic solutions for these types of problems. But we wouldn't be here if that was all this technology is for, and certainly that's far from what we believe. We really do believe that blockchains have the potential to introduce new paradigms for web apps, distributed systems, file transfer protocols. There are any sort of number of problems that we sort of want to solve together that maybe we don't want to trust each other for. And maybe these use cases are so valuable to us that it's worth it to pay the extra cost and to do the extra work and execution to rely on this really inefficient but very beautiful machinery that we all share. And I think there's a lot of work to be done in sort of achieving this ideal. If you look at many blockchain projects today, they sort of fall into one of three categories. Either they're on a blockchain, simply to raise money and for no other purpose. I would say there's like a long tail of projects sort of in this category. Or they put some sort of critical component of their application on a blockchain and centralize something else. That's also an okay model for many projects. Like maybe we'd like to trust the exchange, but we don't want to trust, we don't need to trust the web app. So I'm willing to let you serve me the JavaScript that we use to run an exchange, but I'm not willing to allow you custody of my funds and my money. And this is sort of a lesson cryptocurrency people have learned repeatedly, that if you do have a mutual root of trust, even if it is more efficient and cheaper to do things this way, you really do have to think about how these actors can misbehave. Another example would be social media. So when you go on social media, how do you trust the ranking algorithm to show you posts that are appropriate? How do you trust it not to be manipulating this ordering to sort of influence your actions or your thoughts or anything like this? How do you trust the ads that they're showing you to be from who they say they are, or to even be from like inside like your own country if it's a political ad or something like that? So there are all sorts of problems in our world around trust, and trust minimization is a very, very powerful thing. And I think blockchains are wonderful for this application, despite the fact that they're in many ways expensive and inefficient.
And trusted.
And to a large extent trusted, yeah. Yeah, but at least they're auditable, right? It's you can verify the trust if you have infinite time.
Anyways, great. So I think we had two kind of more technical answers and a little bit more of a social answer. I'm going to give more of like a social kind of answer. To me, the thing that's most interesting about the blockchain, and the reason why we're kind of all here, is that the blockchain is a new kind of international institution, the likes of which we've never seen before. It's user, miner, developer, and it is not founded on the legal tradition. Instead, it's founded on just a kind of technical fault tolerance. The system is designed to handle failure and to cope with failure, but it isn't designed to prevent failure via the threat of legal consequences. And so it provides, it's a kind of international institution that is very different from the international institutions that we have today, and which promises to provide the basis of many new and different international institutions that are not governed inside any one jurisdiction, and therefore can't be caused to fail by any one government or any one judge, and instead must be governed on an international basis within a collaborative way, where decisions have to be considered legitimate on a global basis in order to not lead to forking. So I think the blockchain, from a social perspective, is super interesting because it's a new kind of international institution and the basis for the creation of new international institutions that have to be governed in a globally consensual manner and can't be just coerced by a single jurisdiction. And so to me, that's the thing that I think is the most interesting from a social point of view, and I think is the kind of number one thing that actually brings us together in blockchain space.
Yeah, so I mean, if we just talk about what a blockchain is, these are really good answers, and I don't know actually how much more I can add to that. But I would say that the key insight around it is just that anybody can create a valid history of things that happen on their own, and this tool that allows sort of the world to come to an agreement under certain assumptions, which single history is the one that we're referring to when we talk about what's happened in the past, is a very, very powerful tool, especially when we speak about financial instruments, but also when we talk about social institutions.
Yeah, so for me, a blockchain is simply a tool that allows for people on the internet who don't trust each other to come to agreement on something. And one of the interesting things for me is that what we come to agreement on, the consensus, has actually changed over time. So it started with Bitcoin, where people came to consensus on a specific application, and the flexibility that you had was at the account layer. And Ethereum was, when it came out, Ethereum 1.0 was super exciting because it abstracted away the application layer and provided this execution engine, which was flexible enough to be a platform. And I think with Ethereum 2.0, we're seeing the next evolution of abstraction, where we're kind of taking abstraction of consensus to almost its logical conclusion, whereby consensus is about agreement on arbitrary pieces of data. And what that means is that you can build your own execution engines. So it's possible that Ethereum 2.0, the sharded version, will be even more of an infrastructure thing than Ethereum 1.0. It will be a platform to build your own execution engines upon which you can build your applications.
Wow, that was amazing. With this kind of overarching kind of what is Ethereum, there's a lot of kind of uncertainty around the development of decentralized applications. Like, what are they? How do we actually do this? How will I maintain future compatibility in a sharded world? How do I, create a decentralized application today? And so I'm curious what your takes are on, how, if you were to go about architecting, designing a decentralized applications, where would you start? Where would you go?
So I think those are questions that we actually don't know the answer to as a community yet. And if you would like to help solve the answer to those questions, by the way, I'm part of 2 organizations that are hiring, so please reach out. No, but seriously, I think the real answer in terms of how we build dApps is very carefully. So try to really, really think through and carefully consider what piece of your architecture and what piece of your infrastructure needs these sort of benefits that we've been talking about, and build really the minimum thing that captures that functionality, and then build your system around it. And as time goes on, you can sort of look at how that's been working and ask yourself, are there more pieces of this we want to put into the blockchain? Do we want to move some of it out of the blockchain? Do we want to change the contract, et cetera? In terms of upgrading, that's always a hard problem. There's sort of this fundamental tension between decentralization and upgrading, because in order to upgrade a decentralized application, all of your users need to agree on what the upgrade should be, and there's no clear process for how that happens. There are a bunch of suggested sort of templates that people have explored, including these decentralized shareholder-based organizations where people use tokens to vote on upgrades, etc. But there's not really a good answer. I mean, if you want to create a currency on top of Ethereum that runs forever, you, by definition, cannot create an upgrade mechanism, because then that upgrade mechanism can be used to stop your thing from running. So again, like, these are all really, really hard and fundamental problems, and we're in very early days here, so we're still at the experimental phase of answering these questions.
Yeah, the design of the protocol layer to make sure that it's future-proof is extremely difficult, and I think one of the things we can do today is basically have maximal abstraction, and what that means is that developers have much more power, and that means freedom to experiment. And I think one way that we're going to see the ecosystem evolve is simply lots of experimentation at the beginning, lots of failures, but then the successes will start becoming normalized and standardized, and then once we feel comfortable with these standards might become enshrined and be part of the protocol. And that might be like a similar story to what we've seen with the tokens and the ERC20 standardization. We might see something similar with sharding.
Cool. Well, so we just did this workshop, of course, and I think it would be great if we could give a quick overview of like what is going to sharding phase 1 exists, sharding phase 2, like where are we headed in the kind of near term, and you kind of started touching on it, like how does that prepare us for the future in some way?
Yeah, so I mean, sharding is this extremely ambitious thing that we want to push in the long term, and it's going to be a lot of work, and it's going to take several years. The really good news is that phase 1 is this minimal thing, which seems very much doable, something that we can launch pretty quickly and provide value in the near term. So. This phase 1 has very little features. It's extremely abstract, and so yeah, it's going to be a platform for experimentation, where a lot of the applications might not be suitable for long-term production because there's going to be a lot of failures, but it's still going to be extremely exciting to see the initial development of that.
Yeah, and one of the kind of big themes that we've been talking about for quite some time is this like data availability problem, and also validity of shards. And so when we do create a sharded blockchain, and we now have to deal with large quantities, very large throughput of data, we need some guarantees around that data being there. So like, what is this data availability problem? Is it like a fundamental blockchain issue, decentralized issue, and like how can we start addressing it?
Yeah, so basically, like as far as like desirable properties of a blockchain, right? There is a few, and like it's important to think about them explicitly when we're doing sharding, because like in a traditional single chain system, they are all satisfied, but they're satisfied pretty trivially. So one property is consensus, which is basically, or like agreements, which basically means if two people see some block as being finalized, like whatever finalized means in your consensus protocol, then they should see the same block as being finalized, so they should agree on the history beyond some point. Another is validity. So the thing that the history that they agree on should be a history which is valid. It should not contain transactions that just like grab like my money and send it to like whoever without a signature from me. They should not like just randomly create Ether into existence. They should not just like randomly start changing around code of contracts unless the code itself explicitly does that. A third very important property is availability. And availability basically means that like the data is there and the data is publicly available. So basically, like if you if there is a block that's been published and the blockchain consensus agrees that this block is part of the canonical history, then like it's important that it's even if the block is correct, that everyone is able to actually download it. And this is kind of trivial in like traditional single chain Ethereum because you assume, well, obviously downloading the whole thing is like the first step of validating it. So you don't really you can't even imagine its absence. But once we start thinking about more advanced scalability technologies, including like ways of ensuring validity, like fraud proofs and later on zero knowledge proofs like snarks and starks, like you can realize that it is absolutely possible even to be sure that a block is correct without being sure that you can download it. Or potentially there are these technologies that are guaranteed to like basically tell you if there is a mistake in a block. And so if you don't see one of those messages, you can infer that the block has no mistakes. But these techniques only work if you can separately ensure that the data actually is downloadable. So if there is some fault in the block, that like someone can points the fault out. And the data availability problem is significantly harder than the validity problem because data availability is not a uniquely attributable fault. So what that means is that if someone doesn't publish the data and then someone else complains and then the first person publishes the data right after, you don't really know, like anyone who wasn't watching that specific piece of data right at the time doesn't really know, like was it the first person that did not send the data on time? Was it the second person that didn't see the data on time? Like were they both faulty? And this generally just makes it harder to kind of properly incentivize the blockchain, makes it harder to kind of properly determine like whether or not the blockchain is actually is available. And this is one of those things for which we have been working on kind of several different strategies, but it's definitely significantly harder to ensure than just like proving that blocks are correct if you already assume that the data is there.
So I think fundamentally the data availability problem is a very important problem in computer science and distributed systems. If we're all here and we're sort of sitting in a room, I can shout something at you guys and you can sort of take a vote by your raise of hands who heard me say what. But if we're all sitting on the internet, we don't really have this channel of like me saying something and you all hearing it. What we have are sort of a bunch of point-to-point links between each other. So it can definitely be the case that I send something to Carl and nobody else in this room sees it or even knows whether it was sent or not. That problem is made more complicated by the fact that the internet is sort of this amazing probabilistic routing system where no one on the internet actually knows like the whole internet. When you're on the internet, all you know are the people who are sort of connected in a close zone from where you are. And all you do as someone who's on the internet is sort of forward the packet to someone who you think is closer to its intended recipient than you. This transmission can fail. It does fail all the time. It can take forever. It can take an unbounded period of time. A packet that I send might arrive 0 times, once, 2 times, 3 times, etc. So the internet really gives you no guarantees on the sort of communication that you have with other people. And this makes all of us coming to agreement with each other a very hard problem. You could potentially even have, for example, a split where half the room can talk to each other and the other half can't, or et cetera, selective censorship and many other sort of issues. So data availability is about designing protocols that, despite this unreliable communication mechanism, still work and still give you some guarantees that if there is data somewhere, you can find it within some period of time, or you can find it, or someone's going to have to pay money who claims to have the data, assuming that the internet is working. And then also analyzing the case of if our communication network is not working, what happens, how can we detect it, how can we recover, etc.
And to bring it back to our earlier conversation, the reason why this is an interesting problem is because it's actual trade-off. You might say, well, if there's data availability problem, why don't you just add more data to the network? But that comes back down to how much is like each byte costing for the entire network, right? So the reason why Amazon or Dropbox or what have you can provide the lowest dollar per gigabyte is because they have control over all the servers that they're storing on. So if you have a file, what they would do is they would chop it up into different pieces and use this erasure coding process to make sure that even if you lose X number of those shards, you can get the file back in the most economical way possible. With decentralized systems, it's hard to do that because you don't have control over those servers. So you have to add just the right amount of servers to make sure that I feel that I have the right SLA or service level agreement of having availability without costing infinite money to the network.
Cool. So, I mean, I'm going to push back on something that Phil said, saying that we have no idea how these applications are going to be made. I think that we have an idea, and one of the keys is data availability. And another key is, state channels, and a third key is plasma. No, okay, there's a bunch of different architectures. I'm just a shill. But I'm kind of curious, with respect to data availability, or just in general, like where do these things, design patterns fit in, state channels and plasma, and other architectures that haven't been created? Oh yeah, please push back.
I'm going to be quick since I've been talking a lot. None of those things work yet, so it's really easy to say that we know how to do this, but you haven't proven it. So and none of us have proven it. And I do believe you that it maybe can be proven for many of these systems, but there's a lot of work left to do, and I think that's important to note.
I mean, I think a fairly proven way to do data availability is simply just like how Bitcoin or Ethereum does it right now, where you have this assumption that most of the miners are honest, and then it's kind of an emergent property of this forking and this consensus. And so I think a fairly non-risky strategy to look at these applications is try and replicate that type of data availability with more of it, and that's exactly what we're doing with sharding. So sharding is just more data availability out there, and then that's kind of a very solid base layer to start building things. Plasma is kind of another take at solving this really hard problem of data availability, whereby it's saying, let's try and use external infrastructure that is maintained by these operators or by a group of people, but the data availability is some different mechanism than the emergence from forking rules. And so I think it's going to be very interesting to see which one will win off and what the trade-offs are. But yeah, at the end of the day, the data availability problem is the hardest thing, and we're trying various ways to tackle it. And yeah.
And to talk a bit more about plasma and state channels, in general, right? Like we've talked a lot about sharding, which is this kind of layer 1 scalability solution, in that it tries to increase the capacity of the Ethereum base chain. Another important category of a scalability solution is layer 2 scalability solutions. And the way that I define layer 2 scalability solutions, kind of game theoretically, is that if you assume that there is a contract on the main chain, and the contract has some mechanism, and the mechanism is basically like a game that different participants can play with each other. And the game has some Nash equilibrium. So if all of the participants play rationally, then then the assets inside the contract would or could be distributed in some particular way. And if you personally know that if you have this mechanism and you could play with them, make some kind of actions to that contract that can give you some assets out of the contract, then you can kind of say that you counterfactually those assets. You sort of virtually have them in the sense that you can get them if you want to, but you don't need to get them right now at the moment. And the reason, the scalability part comes from the fact that you can mostly or entirely use off-chain messages in order to make changes to the equilibrium or the expected outcome of this game without actually making like large amounts of, or in some case even any activity on chain. So just by the mere fact that you're exchanging like cryptographically signed off-chain stuff, you're changing the possibilities of what people could do by like sending those messages into this on-chain contract. And so you can make large changes to like basically the amount of money that each person can have if they wanted to. But so you are kind of sending them assets or like performing other operations sort of kind of virtually or counterfactually without actually like doing anything on the chain at all, right? So this is really nice because it basically means that you can perform lots of economic activity without actually significantly touching the underlying base chain most of the time. And like state channels are one strategy of doing this, and Plasma is another strategy of doing this. They both have their different strengths and weaknesses. One example of an application of Plasma is that you can use Plasma to like basically do the same sort of stuff that you're already thinking of doing with centralized services or with consortium chains, and you can do them with the efficiency of like central servers or consortium chains, but at the same time benefit from a lot of the safety of being on an underlying decentralized public chain. Right, so one example is if you have an exchange, then the exchange can kind of wrap itself in a Plasma layer, and it can function like basically in such a way that even if the exchange gets hacked, like all of the users can kind of play this game with signed messages or with an on-chain contract and get all of their money back at any time. And the exchange itself can have very high scalability. It can process like thousands of transactions per second. So like anything you might want to do on a consortium chain, like doing it on a Plasma chain probably makes sense to consider at least at some point. Channels are also good because since they rely purely on off-chain messages, they're also a great latency solution. So basically, as soon as you send someone an off-chain signed message, you can convince them that that if they want to, they can grab money from this on-chain contract. And so you're basically sending them money and they kind of get economic finality of that transaction immediately. So this could be good for consumer payments. This could be good for even like, once again, decentralized exchanges. Like in general, it's good for doing things where you want to complete the operation much faster than waiting for like block confirmations. So like, along with sharding, these are both like exciting avenues that we're kind of interested in and trying to and exploring very actively as well.
Can you clarify the difference between state channels and Plasma, Vitalik? Vitalik?
Yeah. So the difference between state channels and Plasma is that a state, basically, a state channel is a system where you can change the equilibrium or like the expected outcome of the on-chain game, relying purely on off-chain messages, so just like digitally signing pieces of data and sending them to the other participants across the network. Plasma is a hybrid system where you benefit from the additional ingredients that you can also, like there are some participants that can generate a Merkle tree and they publish the Merkle root onto the chain, but like they don't publish the rest of the data onto the chain. And the Merkle root basically acts as this kind of source of uniqueness that basically says, I am committing to this piece of data, and if you have the other data, then you know that you can use that data and check it and kind of authenticate it against the Merkle root, and you can like possibly recover like some other assets if you wanted to. And the main additional kind of power that this Plasma approach gives you is, unlike channels, in Plasma you can basically send assets or like perform operations with arbitrary parties, even parties that haven't already registered with with the system. Like with a state channel, you can only send money to like basically pre-registered participants, whereas with Plasma you can also like basically bring in outsiders and kind of loop them into the system at any time.
So Vlad is the bomb, and he would rather scale using sharding than Plasma. And I'm curious, just like how that vision, like kind of differs. Where do you see, scalability of the main chain?
Yeah, I mean, I think sharding is the only real way to scale the blockchain. I don't consider Plasma or state channels to really be scaling solutions. They only provide a constant factor scaling and not a big O factor scaling. So somehow, like, and they're also like relatively like elementary and boring from a research point of view, in my opinion. So I'd rather not spend any time on Plasma or state channels, except for sometimes for user experience reasons. I'm interested in sharding, and I was hoping we'd talk about sharding.
Yeah, can you talk about sharding, especially all the research that you're doing?
Well, I'm interested in sharding with cross-shard communications, and where like there is atomicity across shards, and where there are no in-protocol fault tolerance thresholds, no like two-phase commits, and I'm not into honest majority assumptions. I'm also not into sharding without any transaction semantics. I believe that like, we should be replicating some kind of computational engine, not some kind of pinboard. So I mean, I have like some strong opinions about how sharding should look. And I mostly work on like kind of long-term vision of like what sharding should be like, and kind of a specification for like an end sharding protocol. I'm not so focused on implementation or development. I follow a kind of like faith-based, ideological, systematic thinking kind of approach, not a pragmatism, can we implement it this year approach. And so like, I'm working kind of mostly independently of the rest of the sharding team. We have the most in common when we're talking about block availability and validity, I'd say. Yeah, sorry to let some of my bitterness come out.
It was lovely, so endearing.
So I do think I'm going to push back a little on what Vlad said, which is that there aren't that many interesting research problems in sharding. I think, in Plasma or state channels. So I think there are really interesting research questions about how to make these systems like actually work and work securely and accomplish the guarantees that you want them to, because just by looking at the spec, it's not intuitively obvious that they do. And I think that sort of as a species, we're really good at building things that scale to billions and billions of users and things that are really fast, but we're sort of less good at building things that work properly all the time. And building something that's a combination of both, I think, is still a really hard problem.
Yeah, so I mean, people have different standards of interesting. And, and to me, like, okay, how things work in practice isn't really my area of interest. Not really. I'm mostly interested in like, what are the mathematical properties of the specification?
But aren't you interested in things that make your cryptographic tokens go up?
Secondarily, like very, very, like not really like my top priority.
Faith-based ideological.
The prices are too high already.
Can you do a rapid, either Phil or Vlad or both, rent spiel, just super quick?
I'll let Vlad start this because he's the real OG on this problem.
Well, I mean, I think it's crazy that the network would bear a cost forever for a revenue borne once by a single party. So think about this. As a miner, I include a transaction and I store some data. I am the only party that gets the revenue there, but every single full node and every single miner for all time will bear the cost of that storage. I don't think that is sensible. I don't think it makes sense. I think, yes, rent is a problem for user experience. I don't really care. But I think that we should build intermediate layers that will make it easier to deal with rent. From my point of view, we should do our best to make sure that as much as possible we're relying not on public goods, but on things that are properly incentivized and paid for by the people who are using them. Basically because this will make the system easier to maintain, more sustainable, and less likely to kind of topple over because of people's eventual unwillingness to provide public goods for free.
So yeah, I think to speak sort of to the broader point, the way I view this research problem is that we really need to come up with a principled framework for thinking through what resources are being exchanged sort of in this blockchain marketplace that exists. and how do we price these resources, and how do we build systems where users can efficiently access these resources for a fair price. So coming up with such a principled framework is far from an easy problem. Even identifying the resources of interest is far from an easy problem. But I completely agree with Vlad in that in the long term, your incentives have to be sustainable or your system won't work. I sort of want to leave this with one more comment, which is that it's really tempting in the short term to prefer a solution which does not have sustainability and which does not have proper incentives, which to an extent is what Ethereum has been thus far with sort of this more ad hoc economic model. And what this is implicitly doing is it's currently subsidizing pretty much all of the transactions we're doing on the blockchain. And people are paying much less than they need to for storage and for other resources they're using. They're not paying anything for the network, and et cetera. So there's a real question of how do we get people to pay for the resources that they're actually using? What are these resources? And what should such an efficient marketplace that would allow for price discovery look like?
One quick additional thought. One way to put it is that the more public goods you have, the more that we need to provide as a community on a free basis. Or another way to think about it is the stronger the assumptions of the protocol, the harder it is to govern, because the more we have to make sure that on an ongoing basis we provide stuff that isn't accounted for in the protocol.
Cool. And so just really quickly, the Ethereum kind of 3.0, just where this Casper sharding in 1, 2 sentences, 5 sentences, Vlad. I want to hear you.
Imagine so much scaling that no one thinks about Plasma. Imagine.
I love it.
Imagine abstract computational engine where people can implement their own virtual machine, but not as a state transition function, but as something actually concurrent, something that's actually a process, not a function. And we can argue about what the differences of that maybe. But basically, so somehow scalability, abstraction, and also security are the 3 main things that there's this kind of low latency idea. Oh, right, here's an exciting one. Heterogeneous sharding, where basically different shards run at different levels of security, latency, overhead, so that different applications could be served based on their various needs. Some application, for example, if you're making a micropayment, perhaps doesn't need to be operated at the same level of security as something that is running something that's super mission critical, and therefore could maybe benefit from a much lower overhead and lower latency. So I think a heterogeneous sharding that's secure, where we have abstraction and security, sorry, I already said security, and scalability is the thing that we want.
I dream of a sharding system that's so secure that we don't need to worry about different levels of security, and we can count on the entire base chain, and micropayments can live on Plasma.
Okay, well, notice I said a number of validators. I guess it's kind of security in some. So I guess when I say security, I'm thinking about the liveness and safety of the consensus on the particular shard, not so much about the validity and availability. Anyway, sorry.
Okay.
Random weird.
One last thing
thoughts.
I promised to the organizers. We never said everyone's names, and so we're gonna say them at the very end so you know who they are, and one sentence, amazing sentence. Just give me a gold sentence.
Yeah, my name is Vitalik. I like cats, I like alpacas, I like meese. Yeah, okay, hi.
How do I beat that? Hi, my name is John Choi. I work at Ethereum Foundation on the research side. Like Frederick said, things are super early. If this is at all interesting to you, come work with us, come solve problems. You don't even have to work directly for the foundation. You can work from anywhere. So join us.
Hi, I'm Phil. I'm a PhD student at Cornell Tech, which is Cornell's new campus in New York City, and I specialize in smart contract security. And sort of my life goal is to figure out how to make Vitalik's cats and alpacas pay their fair share of rent and stop free riding on our system.
You forgot the meese.
And the meese, yes. We
what-
can subsidize those, actually. Yeah.
What are meese? Mooses. Oh, geez. Okay. Anyways, I'm Vlad Zamfir. I work on Casper and Sharding, and I hope we can obsolete proof of work.
Hi, I'm Robert Habermeyer. I don't know any sentences, so I'm just going to leave it at that. But that's true. So actually, I'll just tell you who I am. So I'm a core developer and researcher at Parity Technologies. So I'm working on Polkadot right now, which has many similarities to what we talk about as phase 4 tightly coupled sharding in Ethereum.
I'm Justin Drake. I've been doing research on sharding for about 4 months. It's been super intense. There's lots of low-hanging fruit still to be found. So if you're into that kind of research, do join us because it's a small team and there's lots of work to be done. There's also lots of learning. You know, I've been here for 4 months, and only like about now I feel like I've been able to catch up with all the backlog of stuff that has happened. So yeah, do join us.
Well, thank you, everyone. It's been lovely. Enjoy.
Okay, so thank you for this special guest coming to Taipei to give us this amazing sharing. And also, due to the limitation of the time and the size, we can have everyone come at the stage for the panel discussion. Someone like from Brainboard or L4 or Web3 Foundation. But yeah, thanks again for all of these amazing guys. And we just got, I just got notice from some of our co-organizers from Taipei Ethereum Meetup. So in April, we will have the two coming events. One is on April 6th, and we will have Golden, Joyso, and KillCon. And on April 28th, we will have Menoport, Megadao, Genosis, and Raiden will come into Taipei. So yeah, please, subscribe our Facebook fan page and to get the latest news. So thanks for coming. Thank you. Oh. Yeah.
哎，大家等一下，我们可以来个合照。我们等一下摄影机会从这边开始拍，所以请大家先等一下下。没有他们，请他们过来这里。Hey guys, can we come to here? We can have a group picture. Oh my God, the cats. Hey Vlad, do you want to have a group picture? Yeah. So Ken and I will be here. So let's go here to have a group picture. Alright, thank you today. 好，请大家都站着就好了，请大家都站着，然后我们来一张最后一个合照。Yeah. Please start. Everyone stand up and have a group picture. Anyway. Oops. Can I have a? Everybody, please stand up.